Everyone. Last class we have discussed the topic chemical bonding, right? In which we have discussed different types of chemical bonds, Fajan's rule, what is hybridization, and how to find hybridization of any inorganic molecule and organic molecule, right? Today, we'll understand how to find the shape or geometry of any inorganic molecule from the hybridization, and after which we'll move on to problems from this chapter. Okay? Shall we start the session? Marimuthu, shall we start the session? Okay, fine. So, before getting into the structure geometry of inorganic molecule, I'm going to give you a molecule, an inorganic molecule. Please find the hybridization of that central atom. Okay, is my screen visible? Pundamararisi? Okay, fine. Okay, Kana. Okay.
Yes, madam.
Okay, sir. Okay. So the molecule is ClF3. And which is the central atom here? In ClF3, which is the central atom? Have to find the central atom in the molecule. The atom which is occurring least number of times, right? Here we have only one chlorine and we have three fluorine, right? So chlorine is the central atom. So please find the hybridization of chlorine in ClF3. Last class we have worked out few examples, right? Guys, do you want me to help?
Students, can you reply, because unless you respond, how does she know? Marimuthu, Poom, Damilarasi, Tatvatika, please reply.
Ma'am, please give a minute, ma'am.
Okay, okay. So what is the hybridization? Okay. Hybridization is sp3d. Very good, Tatvatika. Okay, let us do it together. We have two types of atoms. One is chlorine, another one is fluorine. So we have only one chlorine there. And what is the valence electron of chlorine? Chlorine is in 17th group. So what is the valence electron of chlorine? If group number is 17, then the valence electron is 7, right? So 1 into 7 is 7. Okay, how many fluorine atoms are there? 3. And what is the valence electron of fluorine? Again 7, because fluorine is in 17th group. Fluorine is a halogen, right? So 7 to 3 is 21. 21 plus 7 is 28. So what is this 28? It is the total valence electron of ClF3. So you have to divide this total valence electron with which number?
By 8, ma'am.
Very good, because we have to compare this total valence electron with a number 9. If the total valence electron is greater than 9, then we have to divide this total valence electron by 8. If this is less than 9, then we have to divide total valence electron by 2. There is no molecule whose total valence electron will be equal to 9. So we need not worry about that. So here total valence electron is 28. Since it is greater than 9, I have to divide this total valence electron by 8. How many times? 3 times, right? 3 eights are 24. So what is the remainder? 4. So again I have to divide this remainder by 2 because it is less than 9, obviously. So we have to divide it by 2. So how many times? 2 times. Here the remainder is 0. Now we have to add both the quotients. So 3 plus 2 is 5. So if the quotient is 5, then the hybridization is sp3d, right? If the quotient is 2, what is the hybridization? If the quotient is 2, what is the hybridization? SP. Power of S is 1, power of P is 1, 1 plus 1 is 2. If the quotient is 3, then the hybridization is SP2. Power of S is 1, power of P is 2, 1 plus 2 is 3. If the quotient is 4, then the hybridization is SP3. If the quotient is 5, the hybridization is SP3D. If the quotient is 6, the hybridization is SP3D2. And if the quotient is 7, the hybridization is SP3D3. Since the quotient is 5, the hybridization is sp3d. Okay, fine. Please find the hybridization of xenon in XeO3. XeO3. I want you to find the hybridization of xenon in XeO3. Marimuthu, is that clear?
Yes, ma'am.
Okay. Please find the hybridization of xenon in XeO3. After finding the hybridization of this molecule, we'll get into the geometry of the molecule. See, hybridization is very important. In every NEET question paper, you can find one question from hybridization. So it is really, really important. Practice as much as possible. Okay. Okay, fine, Tatvatika. Let us check. Pundamarisi, what is your answer? Okay, Marimuthu, fine. Tony and Pundamarisi, what was your answer? What is the hybridization of xenon? Okay, Poondamil Arasi's answer is also SP3. Tatvatika, what is your question? Can I please repeat your question?
Ma'am, is there any molecule like a CN? Just CN, ma'am.
There is no such molecule. CN will exist as CN minus. CN minus is an ion, and there is no neutral molecule like CN.
Okay,
And
ma'am.
if you want to find the structure of CN, then that is linear because number of chemical bonds between carbon and nitrogen will be 3. So from which we can understand the molecule will be linear. It is not actually a neutral molecule. It is an anion, Cn minus, and whose shape is linear, C triple bond N.
Okay, ma'am. I thought there is no number with hybrid. Total number of electron is 9. So I just thought of carbon and nitrogen, ma'am.
Okay, okay. Actually, it is Cn minus.
Thank you, ma'am.
Okay, Kanna. Okay, so the hybridization of xenon is sp3. Hope you guys are comfortable in finding the hybridization. Now we'll move on to finding the shape of the molecule. Okay, so from the hybridization we can easily find the shape of the molecule. So for that I have a tabular column. Please understand the tabular column, and after that you have to memorize it. Okay, without understanding you cannot memorize. So I'm going to teach you how to find the structure of molecule with each hybridization. Please listen carefully. It will take at least 5 minutes. Please listen here. If the central atom's hybridization is sp, power of s is 1, power of p is 1, 1 plus 1 is 2. which means if the central atom got hybridization as sp, then the central atom can form two sigma bonds. Okay, which means central atom can form two chemical bonds. Okay, if these two bonds are occupied by two atoms, then the shape of the molecule is linear. And what is the bond angle? The angle between this bond and this bond is, if it is linear, what will be the bond angle? Obviously, it is 180, right? Sometimes there are molecule whose central atom will be sp hybridization. A central atom can form two chemical bonds, but that central atom will have only one terminal atom. So we'll work out few examples later. Okay, if both the bonds are filled by atoms, the shape will be linear. In few cases, the central atom will have only one terminal atom, another bond will be empty. Please fill this empty bond with lone pair of electron, still the shape of the molecule will be linear and the bond angle is 180. Okay. Next hybridization is sp2. If the central atom got sp2 hybridization, how many chemical bonds that central atom can form? It is sp2. So how many chemical bonds that central atom can form? Power of S is 1, power of P is 2, 1 plus 2 is 3. So central atom can form 3 chemical bonds, and 3 chemical bonds should be like this. Okay, if all the 3 chemical bonds are filled by atoms, then the shape of this molecule is, say I'm going to connect all these B atoms. So the shape seems to be trigonal planar. And bond angle is 120 degree. Okay, if the hybridization is sp2 but central atom got only one terminal atom, then what happens? We'll be having one empty bond, right? This empty bond has to be filled with lone pair of electron. If in trigonal planar, if we got one lone pair of electron, then this shape is no more trigonal planar. We have to tell this shape as V shape, because please connect all these atoms. It will be like V. So the shape is called V shape. So central atom's hybridization is sp2. Central atom can form three chemical bonds, but in a specific molecule, if the central atom got only two atoms, then then there will be one empty bond, right? That empty bond is filled with lone pair of electron. Then that shape is no more trigonal planar. You have to call that shape as V shape, or it is also called as inverted V, or it is also called as bent shape, or it is also called as angular. Okay, fine. Uh, See, study the bond angle for the molecules what I'm giving. Okay, rest of the bond angles was not necessary. So please study the bond angles what I'm giving to you. Okay, fine. Next, if the central atom's hybridization is sp2, but central atom got only one terminal atom. Okay, so then we'll be having two empty bonds. Both the empty bonds has to be filled with lone pair of electrons. Now we have to check for the shape of this molecule. This is not trigonal planar. Please connect these two atoms. So this seems to be again linear. If it is linear, what will be the bond angle? No matter what, if the molecule is linear, bond angle will be 180 degree. Okay. Next is sp3. How many chemical bonds a central atom can form if the hybridization is sp3?
4, ma'am.
Very good, 4. So, see, central atom can form 4 chemical bonds, in which 2 bonds are in plane bonds and 2 bonds were out of plane bonds. What is out of plane bond? These both the bonds are not on the plane. This bond is above the plane, and this dash which bond is below the plane. Okay, but central atom can form 4 chemical bonds, and if all the bonds are filled by atoms, then the shape is tetrahedral. And what is the bond angle of tetrahedral geometry? What is the bond angle of tetrahedral geometry? Very famous, no? 109.5 degree, right? Or 109 degree 27 minutes. We know 60 minutes is 1 degree. So how about 30 minutes? If 60 minutes is 1 degree, how about 30 minutes? If it is 30 minutes, then what will be the how much will be the degree? It is 0.5 degree, right? Here I have 109 degree 27 minutes. 27 minutes can be approximately, we can write it as 30 degree. If it is 30 degree, then that is 0.5, I mean 30 minutes, then this 30 minutes can be written as 0.5 degree. So tetrahedral's bond angle can be written as 109 degree 27 minutes or 109.5 degree. Both the bond angles are right. Okay. If the central atom got sp3 hybridization, but if the central atom got only 3 terminal atoms, then one bond will be empty, right? See, whenever you're filling the atoms in the bond, please fill this out of plane bonds first. So if I have 3 terminal atoms, please fill this out of plane bonds first. After which I have only one empty bond. This empty bond is filled with one lone pair of electron. So what will be the shape? This is not tetrahedral. In tetrahedral, I got one lone pair of electron. So this is called pyramidal. Okay. So in tetrahedral shape, if we got one lone pair of electrons, please listen. In tetrahedral shape, if we got one lone pair of electron, for each lone pair of electrons, we have to reduce 2.5 degree. So originally it was 109.5 degree. In this pyramidal shape, I got one lone pair. So for each lone pair, we have to reduce 2.5 degree. So what will be the bond angle? What will be the bond angle? 107 degree, right? Let us have an example of this. Okay. Ammonia. Which is the central atom in ammonia? Which is the central atom? Nitrogen. Please find the hybridization of nitrogen in ammonia. What is the hybridization of nitrogen in ammonia? Oh, no, no. It is not sp2, Tatvitika. Tony, what is the hybridization of nitrogen in ammonia? Okay. Marimuthu's answer is sp3 and it is right because the central atom is nitrogen. We have only one nitrogen and the valence electron of nitrogen is 5. So 1 into 5 is 5. Hydrogen, I have 3 hydrogens and the valence electron is 1. So 3 into 1 is 3. So 5 plus 3 is 8 and it is less than 9. So I have to divide this 8 with 2. So this is 4 times, remainder is 0. If the quotient is 4, then the hybridization is sp3. So hybridization of nitrogen is sp3. So nitrogen can form 4 chemical bonds. Among 4 chemical bonds, 2 were in plane bonds and 2 were out of plane bonds. So whenever you're filling the atoms in the bond, first fill the out of plane bonds. So I have 3 hydrogens as terminal atoms. So I'm going to fill this bond with one hydrogen, this bond with one hydrogen, and I have one more hydrogen, right? So here I'm going to have another hydrogen. Now I have one empty bond. So this empty bond is filled with one lone pair of electron. So what is the shape of ammonia? Though the hybridization is sp3, though the nitrogen can form 4 chemical bonds, all the 4 chemical bonds are not are filled with atoms, right? There is one empty bond in which we filled lone pair of electrons. So this is no more tetrahedral. What is the shape of ammonia then? In tetrahedral shape, if we got one lone pair of electron, then what would be the shape? It is pyramidal, right? Is that clear? Okay. Apundamil is that clear?
Yes, ma'am.
Okay. If the central atom can form four chemical bonds, in which I have two empty bonds, okay, and rest of the bonds are filled with atoms. Then again, this is no more tetrahedral. This shape is called bent shape, or it is also called as V shape, or it is also called as inverted V, or it is also called as angular. So now we have to check for the bond angle. As I've told you already, generally the tetrahedral's bond angle is 109.5 degree, and for each lone pair of electrons, we have to reduce 2.5 degree. As far as this structure is concerned, we have two lone pair of electrons. So we have to reduce 5 degree in total, right? So what is the bond angle? It is 104.5 degree. Okay, fine. If the central atom's hybridization is sp3, but the central atom got only one terminal atom, then rest of the bonds, only one bond will be filled with atom, and the rest of the bonds will be empty, right? So how many lone pairs will be having in this case? How many lone pairs will be having in this case? We have only one terminal atom. So I'm going to fill this terminal atom here, and I have no chance I have to put lone pair here also. So what would be the shape? It is linear again. And if it is linear, bond angle is obviously 180. Okay. Now tell me, what is the hybridization of H2O? Central atom is oxygen. Please check for the hybridization of oxygen. What is the hybridization of oxygen and water? We have two hydrogens, valence electron is 1. We have only one oxygen, valence electron is 6. So 2 plus 6 is 8. So total valence electron is less than 9. So we have to divide 8 with 2. So quotient is 4. Then the hybridization is sp3, right? So oxygen can form four chemical bonds, but oxygen got only two terminal atoms, right? So I'm going to fill one hydrogen here, another hydrogen here. So rest of the bonds are filled with lone pair of electrons. Now tell me, what is the shape of water? It is not tetrahedral. What is the shape of this water molecule? V shape. That's it. Okay. Now V shape, or it is also called as bent, or it is also called as angular. Anything is right. How about HCl? Before finding the hybridization, now tell me which is the central atom? Is it hydrogen or chlorine? See, hydrogen can never be a central atom. To be a central atom, that central atom has to form minimum two chemical bonds. But hydrogen's valency is 1. In any scenario, hydrogen cannot form two chemical bonds. Okay, so hydrogen can never be a central atom. So in this case, chlorine is the central atom. So please find the hybridization of chlorine in HCl. Hybridization of chlorine in HCl. sp3, very good. So chlorine can form how many chemical bonds? Four chemical bonds, right? But chlorine got only one terminal atom, which is hydrogen. So I'm going to fill this hydrogen here, and rest of the bonds are filled with lone pair of electrons. Now, what is the shape of this HCl? It is linear. Okay, so this is how we have to use that tabular column. Is that clear? Okay. Okay. Next hybridization is sp3d. If the hybridization is sp3d, the central atom can form 5 chemical bonds: 1, 2, 3, 4, and 5. Uh, all the 5 bonds are filled with atoms. Then what would be the shape? What would be the shape? Trigonal bipyramidal, right? Trigonal bipyramidal. What are all the bond angles present in trigonal bipyramidal structure? See, there is a bond angle here, right? Angle BAB. What is the bond angle here? It is like a triangle shape, no? So what will be the bond angle? It is just 120 degree. Okay. And we have to check for the bond angle between B, A. To differentiate this, I'm going to write it as B prime. What is the bond angle between B, A, B prime? It is actually seems to be linear, right? Because central atom is A, which is on the plane, but both the B's are out of plane. One B is above the plane, another B is below the plane. So the bond angle between this is 180. Okay. Then what is the bond angle between B, A, and B? Here, one B is out of the plane, another B is in plane. So what will be the bond angle? It is 90 degree. Okay. So to differentiate this, I'm going to write B double prime. So bond angle between BA, B double prime is 90 degree. Okay. So another structure. If the hybridization is sp3d, central atom can form 5 chemical bonds. Among 5 chemical bonds, we have one lone pair and rest of the bonds are filled with terminal atoms. Then what would be the shape? Originally it was trigonal bipyramidal, but in trigonal bipyramidal we got one lone pair of electron. Then this shape is called seesaw, or it is also called as distorted tetrahedral. Distorted tetrahedral. Is that clear? Okay. Example, SF4. Please find the hybridization of sulfur in SF4. What is the hybridization of sulfur in SF4? See, by memorizing that tabular column, you can answer all the questions which are related to hybridization. So that tabular column is very, very important. Please spend some time in memorizing the tabular column, okay? Yes, the quotient is 5 Tatvatika, and right Marimuthu, the hybridization is sp3d. Yes. So central atom, that is sulfur, can form 5 chemical bonds, right? But as far as SF4 is concerned, how many terminal atoms are there? Only 4 terminal atoms. So all the 4 atoms has to be filled in this chemical bond. So first we have to fill this out of plane bond, and I have 2 more fluorine atoms, 1 and 2. Now one bond is empty, in which I'm going to fill lone pair of electron. So what is the shape of SF4? What is the geometry of SF4? It is seesaw. Is that clear? Is that clear? Okay. Shall we move on to next structure? Yes. Okay, Marimut. Fine. If the hybridization is sp3d, central atom can form 5 chemical bonds, but central atom got only 3 terminal atoms. So 1, 1, 2, and 3. And rest of the bonds are filled with lone pair of electrons. Now the shape of this molecule is T shape. See, this molecule seems to be T, right? So the shape of this molecule is T shape, and we have to know the bond angle of T shape. It is very easy. See, this is T. What is the bond angle? Obviously 90-degree. Okay, fine. Another shape. If the hybridization is sp3d, central atom can form 5 chemical bonds, in which central atom got only 2 terminal atoms. So what would be the shape? Now you guys tell me what would be the shape. In trigonal bipyramidal, I have only 2 terminal atoms and rest of the bonds are filled with lone pair of electrons. Now tell me what would be the shape of this molecule? Very simple. Connect all those atoms and see what shape you're getting. Connect all those atoms. What is the shape? It is linear. It is just linear. Fine. That's it. If the hybridization is sp3d2, central atom can form how many chemical bonds? Power of S is 1, power of P is 3, power of D is 2, 1 plus 3 plus 2 is 6. So central atom can form 6 chemical bonds, in which 4 bonds was in plane and 2 bonds were out of plane. So all the bonds are filled with atoms. So what is the shape? This is called octahedral. Fine, this is called octahedral. In octahedral, if you got one lone pair of electron, that is, if the central atom's hybridization is sp3d2, but the central atom got only 5 terminal atoms, then one bond will be filled with lone pair of electrons, right? So in octahedral structure, we'll be having one lone pair of electron. Then that shape is called square pyramidal. Let me write it here. If the hybridization is sp3d2, central atom can form 6 chemical bonds. In which central atom got only 5 terminal atoms. 1, 2, 3, 4, 5. So one bond is filled with lone pair of electrons. So this shape is called square pyramidal. If the hybridization is sp3d2, central atom can form 6 chemical bonds, but this molecule got one. If the central atom got only 4 terminal atoms, then there will be 2 lone pair of electrons, right? I'm going to fill rest of the bonds with atom. Then this shape is called square planar. That's it. Finally, we have only one hybridization, which is sp3d3. If the hybridization is sp3d3, what would be the expected geometry? If the hybridization is sp3d3, then what would be the expected geometry? It is pentagonal bipyramidal, right? These were all 11th standard syllabus, right? So I thought you guys are familiar with it. So hybridization is sp3d3. So central atom got capacity to form 7 chemical bonds. So A, 1, 2, 3, 4, 5. And we have 2 more bonds, right? Both the bonds were out of plane bonds. 6 and 7. So totally 7 chemical bonds. And the geometry of this molecule is pentagonal bipyramidal. What is the bond angle here? It is 72 degree. Okay. So bond angle between BAB is 72 degree. That's it. There is a final shape here. In sp3d3, central atom can form 7 chemical bonds, but in a molecule, if the central atom got only 6 terminal atoms, then one bond will be empty, right? That one empty bond will be filled with lone pair of electron. Then that shape is called distorted octahedral. That's it. Please memorize all these structures in hybridization. Okay, definitely we'll I mean one question will be asked from hybridization. Okay, so this is distorted octahedral. That's it. Fine. So please memorize these table, guys. Now we'll work out few questions from chemical bonding. The questions what I'm going to discuss today is from Neet previous question. So questions from 2017 to 2024. Okay. Please, we'll work out now. Okay. The first question. The intramolecular hydrogen bonding is present in which of the following molecule? You have to find the molecule where intramolecular hydrogen bonding is present. What is intramolecular hydrogen bonding? Last class we have discussed what is hydrogen bonding and different types of hydrogen bonding and all that. So you have to find the molecule in which intramolecular hydrogen bonding is present. If the hydrogen bonding is formed within the molecule, then that is called intramolecular hydrogen bonding. Any idea? Marimuthu, any idea? Tatvatika? Do you want any clue? Okay. I'll
Yes.
write the... Yes, Tatvatika?
Ma'am, any clue?
Okay, I'll write the actual structure of these molecules. Okay, so first one is basically it is phenol because benzene with one OH, basically it is a phenol, but in meta position we have nitro group. So the structure would be OH, and here nitro group has to be written as N double bond O single bond O minus. Nitrogen's maximum capacity is 3. Here nitrogen use its lone pair of electrons to form fourth chemical bond. So nitrogen will have positive sign. Okay. So this is the structure of meta-nitrophenol because nitro group is present at the meta position. So this is option A or option 1. In second option, the compound is hydrogen fluoride. So there is a chemical bond between hydrogen and fluorine. So electronegativity of fluorine is obviously greater than hydrogen. So fluorine will have partial negative charge and hydrogen will have partial positive charge. And in option C, we have this is phenol, and to the adjacent carbon we have nitro group. This position is nothing but ortho position. So this is called orthonitrophenol. I have OH here and nitro group here. N double bond O, single bond O minus, and nitrogen will have positive sign. And fourth option, what is the name of this compound? This is meta-nitrophenol, and this is orthonitrophenol. And what is this? Fourth option. What is this?
It
Nitro
is
group is... Yes,
phenol,
yes.
ma'am.
Very good. It is para-nitrophenol. Nitro group is present at the para position. So this is OH and this is your nitro group. That's it. So we have to check for the molecule which got intramolecular hydrogen bonding. So definitely HF will not be the case, because in one HF molecule we have one hydrogen and one fluorine. Hydrogen got partial positive charge and fluorine got one negative charge. So there is no hydrogen bonding within the molecule. If a beaker contains HF compound, then hydrogen bonding will be formed between this partial negative fluorine and partial positive hydrogen. So this is called hydrogen bonding, but the hydrogen bonding is formed between the molecule, right? So this is called intermolecular hydrogen bonding. So this is not the case. Okay. But as far as compound C is concerned, which is orthonitrophenol, I have alcohol here. There is a charge separation between oxygen and hydrogen, because electronegativity of oxygen is very much greater than hydrogen. So oxygen will have partial negative charge and hydrogen will have partial positive charge. And among nitrogen and oxygen, obviously oxygen is highly electronegative, so oxygen will have partial negative sign. So this negatively charged oxygen and this positively charged hydrogen will form a hydrogen bonding, and this hydrogen bonding was formed within the molecule. So this hydrogen bonding is called intramolecular hydrogen bonding. Fine. In option A and in option D, both the compounds we had alcohol and we had nitro group, but the problem is distance. Here in option C, alcohol and nitro group were present at the adjacent carbons. So intramolecular hydrogen bonding was possible, but because the distance is very much lesser, right? But in option A and D, nitro group and alcohol were very far, so hydrogen bonding was not possible. Intramolecular hydrogen bonding was not possible. So the answer is option C. Is that clear? Fine. Now we'll move on to next question. See, we have to match list 1 and list 2. In list 1, we are provided with compounds, and in list 2, we are provided with shape or geometry. We have to match the following. So it is very easy. It is very, very direct question from hybridization. So check for the hybridization and check for the shape using the tabular column, and please match those. So after finding the shape of one molecule, please screen the options, okay? Do you want any help? I'll give you 30 seconds. Please work out and tell me the answer. Marimuthu, do you want any clue or do you want any help, Kanna?
I want a help, ma'am.
Okay. Take this NH3 molecule. Please find the hybridization of nitrogen. Okay. In NH3, the central atom is nitrogen. So we have to check for the hybridization of nitrogen. So here we have two types of atoms. One is nitrogen, another one is hydrogen. How many nitrogen atoms are there? Only one. And how many hydrogen atoms are there? It is three, right? What is the valence electron of nitrogen? Nitrogen is in 15th group. So what is the valence electron of nitrogen? Since it is in 15th group, the valence electron of nitrogen is 5. Yes. So 1 into 5 is 5. Hydrogen's valence electron is 1. So 3 into 1 is 3. So 5 plus 3 is 8. So total valence electron is less than 9. So we have to divide this 8 by 2. So it is 4 times. Remainder is 0. If the quotient is 4, then the hybridization is sp3. If it is sp3, nitrogen can form how many chemical bonds? Four chemical bonds, right? Among four chemical bonds, two bonds were in plane and two bonds were out of plane. So the central atom nitrogen got three terminal atoms. So three hydrogens I'm going to fill here. So in originally it was tetrahedral shape, but in tetrahedral shape we got one lone pair of electrons. So what would be the shape now? In tetrahedral we got one lone pair, so it is pyramidal. Okay, it is not square pyramidal. When we'll get square pyramidal shape? In octahedral, if we got one lone pair of electron, then that is square pyramidal. It is just pyramidal. So answer would be trigonal pyramidal, right? So for A, the match is 1. So obviously the answer is option C. Is that clear? Is that clear? You want me to work out rest of the molecules? If so, please tell me, we'll work out together. Shall we work out for BRF3, BRF5? Shall we? We'll work out, but we'll work out together, okay? BRF5, in which we have two types of atoms. One is bromine, and another one is fluorine. So, how many bromine atoms are there? Only one. And what is the valence electron of bromine? Bromine is in 17th group. So, what is the valence electron of bromine?
7, ma'am.
7. So 1 into 7 is 7. As far as fluorine is concerned, we have 5 fluorine atoms. And what is the valence electron of fluorine again? It is 7. So 7 fives are 35. So we have to add this 35 with 7. So what is the total count? It is 40. 42. So 42 is greater than 9. So you have to divide this 42 by 8. How much time? 5 eights are 40, right? Remainder is 2. So you have to divide this 2 with 2 again. So quotient is 1. So remainder is 0. So we have to add these two quotients. 5 plus 1 is 6. If the quotient is 6, then the hybridization is sp3d2, right? If the hybridization is sp3d2, bromine can form how many chemical bonds? Bromine can form 6 chemical bonds. But in this molecule, bromine got only 5 terminal atoms, right? So I'm going to fill all the 5 terminal atoms here. 1, 2, 3, 4, 5. Now one bond is empty. This empty bond is filled with one lone pair of electrons. So what is the shape? Originally it was octahedral. But in octahedral, I have one lone pair of electrons. So this is no more octahedral. It is called square pyramidal. So BRF3's shape is square pyramidal. So for B, it is 4. Okay. So similarly, we have to work XCF4 and SF6. Last time we have worked out for SF6, I guess, right? Can you please tell me what is the hybridization of SF6? SF6. Marimuthu, is that clear? Marimuthu? If you guys want me to work out for rest of the molecule, we'll work out together. Please tell me. We'll work out. Shall we? Shall we work out for XCF4? Okay, we'll work out for XCF4. So here I have only one xenon. What is the valence electron of xenon?
8.
Valence electron is 8. So 1 into 8 is 8. And valence electron of fluorine is 7. Right? So 4 into 7 is 4 into 7 is 28.
28.
28 plus 8 is, yes, very good. 28 plus 8 is 36. So we have to divide this 36 by 8. How many times? 36 by 8 is how many times? 4 times, right? 4 eights are 32. So what is the remainder? 4. So we have to divide this 4 with 2. So how many times? 2 times. So the remainder is 0. So the quotient is 4 plus 2, which is 6. So the hybridization is sp3d2. So xenon can form 6 chemical bonds. 1, 2, 3, 4, 5, and 6. But xenon got only 4 fluorine atoms. I'm going to fill 4 fluorine atoms here. So I got 2 lone pair of electrons. Originally it was octahedral according to valency bond theory, but now I got lone pair of electrons, right? So in octahedral, if we got 2 lone pair of electrons, then the shape is square planar. All these shapes were in that tabular column. That is why I've asked you to memorize the tabular column. Okay. So for CF4, it is 2, right? Okay. Finally, SF6. So we'll work out together. Please answer my questions. SF6. Here, the central atom is sulfur. So how many sulfur atoms there? Only one. So what is the valence electron of sulfur?
6, ma'am.
Sulfur is in 16th group. So what is the valence electron of sulfur? 6. Very good. So what is the valence electron of fluorine? 17th
7.
group. 7. So 1 into 6 is 6. 6 into 7 is 42. So 42 plus 6 is 48. So we have to divide this 48 by 8. How many times? How many times? 6 times.
6.
Remainder is 0. So the quotient is 6. Then the hybridization is sp3d2. Right. Sulfur's hybridization is sp3d2. So sulfur can form how many chemical bonds?
6 chemical bonds.
And all the 6 chemical bonds got fluorine atoms, right? So no problem. So the shape is octahedral. That's it. So for D, it is 3. So obviously answer is option C. Is that clear? Is that clear? Shall we move
Yes,
on to
ma'am.
next question? Okay, Kana. Marimutu, do you have any doubt?
No, ma'am.
Okay. Next question. Here also, we have to match the following. We have list 1 and list 2. List 1, we got molecules, and list 2, they have given you the number and type of bonds between carbon atoms, and we have to match the same. This is based on the hybridization and nature of bonds in organic compound. So please, I'm going to give you 30 seconds. Please work out from your end. If you find any difficulty, please let me know. We'll work out together. Ethane, ethene, carbon molecule, ethine. So how about ethane? How about ethane? What is the formula of ethane? Eth is 2 carbon system. Yes, Tatvatika.
C2H6, ma'am.
Ethane. Yes, it is C2H6, but what is the formula? You're telling me the molecular formula, which is right, but I'm asking the actual formula, how to write that C2H6 chemical formula.
CH3, CH3, ma'am.
Very good. CH3, CH3. So, or this can also be written as carbon, single bond carbon, and each carbon is connected with three hydrogen atoms. So, how many chemical bonds are between two carbon atoms? It is only one. And that chemical bond is nothing but your sigma bond, right? So, for A, we have to match three, right? Between two carbon atoms, we have only one sigma bond, right? See, guys, listen. If there is a single bond, then that is sigma bond. If there is double bond, among which one is sigma, another one is pi. If it is triple bond, among which one is sigma and rest of the bonds were pi. So among these two carbon, I mean between these two carbon atoms, we got only one bond, which is single bond. Then that is supposed to be sigma bond, right? So as far as ethane is concerned, we have only one sigma bond between two carbon atoms. So for A, it is 3. So definitely C and D were ruled out. Okay. How about second compound ethene, which means this is two carbon system. Since it is ene, there should be a double bond between two carbon atoms, and rest of the carbons has to be satisfied by the hydrogen atoms. So between these two carbon atoms, we got double bond. Among double bond, one is sigma, another one is pi. Now tell me which to be matched. One sigma, one pi. So for B, it is 4, right? Okay. And for ethyne, what is the formula of ethyne? Eth is two carbon system. Since it is ine, it is triple bond system. So we have to balance the valency of carbon. So how many chemical bonds between two carbon atoms? We got three chemical bonds, which is triple bond. In triple bond, we got only one sigma and two pi bonds, right? So which will be the right option for D? So in triple bond, one is sigma and rest of the bonds were pi. So for D, which is the match?
Option 1, ma'am.
That's it. So for D, this is 1. So obviously the answer is option A. Is that clear? Now we'll check for option C. They are talking about carbon molecule, and specifically they told carbon molecule is a diatomic molecule. So we have to find the number of chemical bonds between two carbon atoms or number of chemical bonds in a diatomic molecule. To find the number of chemical bonds or the bond order or the bond multiplicity of diatomic molecule, which concept we have to use? To find the bond order or bond multiplicity, which concept we have to use? There is a theory, MOT, molecular orbital theory, right? So we have to use this MOT to find the number of chemical bonds between two carbon atoms, okay? Which is very simple. You have to draw the MOT diagram, molecular orbital diagram for this carbon molecules, and we have to check how many bonds are there, okay? Let us do it here. As far as carbon atom is concerned, what is the atomic number of carbon?
6,
Atomic number
ma'am.
is 6. The electronic configuration is 1s2, 2s2, 2p2. So we have two carbon atoms. Both the carbon atom got a same electronic configuration. So the valency shell is second shell. So I'm going to draw the MOT here. So I'm going to draw it in the energy scale. As we move up, the energy is getting increased. So I'm going to divide this molecule into three segments. This is one carbon atom. This is another carbon atom. Both the carbon atoms combine together to form carbon molecule. So as far as carbon atom is concerned, 2s and 2p were valency shell, in which 2s got lower energy and 2p got higher energy. And in similarly for second carbon atom, 2s got lower energy and 2p got higher energy. Now these 2s orbitals, 2s orbital of one carbon and 2s orbital of another carbon will combine together. Atomic orbitals combine together to form molecular orbital. Here, here two 2s orbitals going to combine. So how many molecular orbitals will form? If two atomic orbital combines together, then we'll end up with two molecular orbitals, in among which one will have higher energy, another will have lower energy. So two atomic orbitals combine together to give two molecular orbitals. One is of higher energy, another is of lower energy. S orbital and s orbital combines together to form sigma bond. This is 2s and this is also 2s. So this is called sigma 2s. So this is also sigma 2s. Among these two sigma 2s orbitals, which got lower energy? This one. So this is called bonding molecular orbital, and this got higher energy. So this is called anti-bonding molecular orbital. Always you have to represent this anti-bonding molecular orbital with asterisk sign. Okay, that's it. So I'm going to connect all those atomic orbitals and molecular orbitals together. Okay. Now, as far as 2p is concerned, how many orbitals going to combine? In one carbon, we have three 2p orbitals. Another carbon, we got another three 2p orbitals, right? How many atomic orbitals going to combine here? 3 plus 3? 6, right? So, 6 atomic orbitals combine together to give how many molecular orbitals? Six atomic orbitals combined together to give 6 molecular orbitals. Okay, among which 3 molecular orbitals will have higher energy and 3 molecular orbitals will have lower energy. Is that clear? So 3 molecular orbitals will have higher energy and 3 molecular orbitals will have lower energy. Okay, so this is px, this is py, and this is pz. This is px, py, and pz. If pz orbital combine together along z axis, then the molecular orbital will be sigma bond. Okay, so here this is sigma 2pz, this is sigma 2pz. But among these two sigma 2pz, this got higher energy, which is anti-bonding molecular orbital, right? So we have to represent anti-bonding molecular orbital with star sign. Okay, rest of the molecular orbitals were pi 2px, pi 2py. This is pi star 2px, this is pi star 2py. That's it. So I'm going to connect all those molecular orbitals. That's it. We have done with the molecular orbital diagram. Now we're going to fill the electrons here. And finally, we'll find the answer for C2 molecule. Okay, in 2s orbital, how many electrons are there? In 2s orbital, how many electrons are there? 2. In 2p orbital, how many electrons are there? It is again 2, right? Similarly, for this carbon also, in 2s we got 2 electrons, and in 2p we got 2 electrons. So after molecular orbitals are formed, electrons from the atomic orbitals now has to move to molecular orbital, right? So as far as 2s orbitals are concerned, we have totally 4 electrons, 2 from one carbon and 2 electrons from another carbon, right? So totally we have 4 electrons here. So whenever you're filling the electron, according to half-pass principle, you have to fill the lower orbitals first. So accordingly, I'm going to fill 2s orbital first. Each orbital can accommodate maximum of 2 electrons. I have totally 4 electrons. Among 2 electrons I've filled here, I have 2 more electrons I'm going to fill in sigma star 2s. Okay, that's it. Now we'll move on to 2p. In both the 2p's, totally how many electrons are there? In one 2p, we got 2 electrons, another 2p, we got 2 electrons. Total of 4 electrons, right? I'm going to fill all those 4 electrons in molecular orbital. So after sigma star 2s, the next higher energy is pi 2px and pi 2py, but both the orbitals are of same energy. Whenever you are filling the orbitals of same energy or degenerate orbitals, you have to half fill the orbitals before completely filling it according to Hund's rule, right? So we have 4 electrons, 1, 2, 3, 4. That's it. Now they're asking for number of chemical bonds between two carbon atoms. Now you have to check only here. Here electrons are filled at pi 2px and pi 2py, which means we have two carbon atoms, and between these two carbon atoms we'll be having only pi bonds. How many pi bonds, how many pi orbitals are filled here? 2. So between two carbon atoms we'll be having 2 pi bonds. So the answer is this one. Okay, so for finding the bond order or bond multiplicity or number of chemical bonds between two carbon atoms in diatomic molecule of carbon, then you have to go for MOT diagram. See, finding bond order generally is very easy, for which there is a shortcut also. I'll teach you the shortcut. Without drawing this MOT diagram, we can find the bond order. But whenever they're asked for specific type of bond or whenever they're asking for magnetic property, then definitely you have to draw this MOT diagram. So please make sure you understand this diagram, okay? Fine. Let us move on to next question. Fine. Next question. Identify the correct statement among the following. The first statement is dipole moment of NF3 is greater than that of NH3. Second statement is three canonical forms can be drawn for carbonate ion, CO3 2 minus ion. Option 3, three resonance structures can be drawn for ozone. Option D, BF3 has non-zero dipole moment. Among these statements, we have to find the correct statement. Okay, please tell me which are all the wrong statements here. At least you must know at least one or two statements, right? Okay, let us start from option 4. BF3 has non-zero dipole moment. Is that true? What is dipole moment? What is dipole moment? If positive charge and negative charge are separated by a particular distance, then dipole moment is nothing but it is the product of the charge of the charge and the distance between the charges. So the magnitude of the charge and the distance between the charge you have to multiply to get the dipole moment. So as far as dipole moment is concerned, it is directly proportional to the magnitude of the charge, and it is again directly proportional to the distance between the charges. Okay, so now we'll check for BF3 molecule. So to find the dipole moment, first you have to know the geometry of BF3. So to find the geometry, obviously you have to know the hybridization of boron. So what is the hybridization of boron in BF3? Again, the same rules. Central atom is boron. So we got only one boron here, and the valence electron of boron is 3 because it is in 13th group. Fluorine, we got 3 fluorine. Fluorine is in 17th group, so the valence electron is 7. So please add and tell me the hybridization of boron. Or please tell me the hybridization of boron itself. Yes, Tatvatika, it is sp2 hybridized boron. So boron can form three chemical bonds because the hybridization of boron is sp2. So boron can form three chemical bonds, and three chemical bonds are filled with fluorine atoms. So trigonal planar is the shape of BF3. So to find the dipole moment of any molecule, please check for the electronegativities. Okay, among boron and fluorine, fluorine is highly electronegative. So all the fluorine atoms will have partial negative sign, and boron will have partial positive sign, right? So to find the dipole moment, what is the rule? There should be a proper distance between positive and negative charge. Here we have only one positive charge, and but we have three negative charges. So we have to connect all these negative charges together to find one negative point. Okay, so please connect all these negative charges. By connecting, we can come up with a shape, right, which is a triangle shape. What is the center of the triangle? This point, right? Already we have one positive center, which is boron. Now we found another negative center also. By connecting all the negative charges, we got one triangle shape, and the center of the triangle is also at the boron. Now there is no distance between positive and negative centers, right? Because both the centers coincide together, right? So there is no distance between positive and negative sign. So here there is no distance between the charges. So D is 0. So dipole moment of BF3 is also 0. Okay. But here the statement is BF3 has non-zero dipole moment, which is wrong. Is that clear? Is that clear?
Yes, ma'am.
Fine. Now we'll move on to first statement because this is also related to dipole moment. The statement is dipole moment of NF3 is greater than that of NH3. So again, we have to check for the hybridization, and we have to draw the structure of NF3 and NH3 to compare the dipole moments of both the molecule. So in both the molecules, the central atom is nitrogen, and the hybridization of nitrogen in both the cases were sp3. So nitrogen can form four chemical bonds in which one bond will be empty and rest of the bonds will be connected with terminal atoms. So obviously the shape is not tetrahedral. The shape of both the molecules were pyramidal. Okay. If you got time, please apply the rules and check for these shapes. Okay. So both NF3 and NH3 got pyramidal shape. Okay. So to understand the shape better, I'm going to draw the pyramidal shape like this. So to visualize the molecule better, I've drawn the shape like this. Okay, this is NF3. This is NH3. Definitely, there will be a charge separation in both the molecules. So let us take ammonia. Among nitrogen and hydrogen, which got more electronegativity? Which got more electronegativity? Obviously nitrogen. So nitrogen will have partial negative charge and rest of the hydrogen will have partial positive charge. Right? Now I got one negative center, but I got three positive centers, right? So to find one positive center, you have to connect all those positive charges together. After connecting the positive charges, we came up with the shape of a triangle, right? Where is the center of the triangle? Here, because all the hydrogen atoms were at the on the plane, right? So triangle will also be on the plane, so center of the triangle will be also on the plane, but nitrogen is not on the plane. It is actually it is projecting on the plane, right? So it is projecting above the plane, so definitely there is a charge separation between positive and negative charge, or there is a distance between positive and negative sign. So we have D here. So here dipole moment is not equal to 0. Similarly, in NF3, which got more electronegativity? Nitrogen or fluorine?
Fluorine, ma'am.
Fluorine. So fluorine will have partial negative charge and nitrogen will have partial positive charge. So we have one positive center at the nitrogen. Now I got three negative charges. I'm going to connect all those negative charges to find the negative center. Here, the negative center will be on the plane. Now, definitely there is a distance between positive charge and negative charge. So there is a distance here. So distance is not equal to zero. So definitely dipole moment is not equal to zero. So both NF3 and NH3 got dipole moments. And now we have to check which molecule got a greater dipole moment. Okay. Uh, any guesses which molecule will have greater dipole moment? I'm just asking you to guess. I'm not expecting the right answer. I'm asking you to guess.
NH3, ma'am.
How, Marimuthu? Why not NF3? But your answer is right, but I'm asking for the justification. Is that a guess, or you got any justification for that? Fine. See, what is dipole moment? It is the product of charges. I mean, it is the product of magnitude of the charge, which is q, and the distance between the charge. In both the case, we got d, and the value of d is more or less same. But dipole moment is depending on another parameter, which is q. Right now, we have to check for the magnitude of charges in both the cases. In both the cases, we got charge separation. But in which case the charge separation was more? Obviously, what we'll be thinking is in NF3, fluorine got higher electronegativity. In periodic table itself, fluorine is highly electronegative atom, right? What we'll be expecting is fluorine got higher electronegativity, so charge separation will be more in NF3. But actually, that is not the case here. Here, as far as NF3 is concerned, fluorine got highest electronegativity, but nitrogen is also not least electronegative. Nitrogen is also highly electronegative, right? So fluorine will pull electron towards itself, but nitrogen is also nitrogen also will pull electron towards itself also. So nitrogen is not a weaker one. But in ammonia, nitrogen is a very strong atom. This nitrogen atom can pull the central atom towards itself. But hydrogen is a weaker one. So hydrogen cannot pull the electron. So there will be a charge separation more in NF3 than in more in NH3 than NF3, because the electronegativity difference between nitrogen and hydrogen is more than in nitrogen and fluorine. Okay, so here Q value will be more, here Q value will be less because of the electronegativity difference between nitrogen, fluorine, nitrogen, and hydrogen. Now tell me which got more dipole moment among these two molecules. NH3 got more Q value. Dipole moment is directly proportional to Q. So here Q is more, dipole moment is also more, right? So the statement here is dipole moment of NF3 is greater than NH3 is wrong. Okay, fine. Now we have to check for rest of the statements. They are talking about resonating structures. The second statement is three canonical forms can be drawn for CO3 2 minus ion. Is that right? Which is the central atom in carbonate ion? Carbon. Carbon is connected with three oxygen atoms, right? So carbon is connected with three oxygen atoms. What is the valence electron of carbon? What is the valence electron of carbon? Carbon is in 14th group. So what is the valence electron of carbon?
4, ma'am.
4. So 4 electrons can be distributed around this carbon atom, and carbon atom is connected with 3 oxygen atoms. 1, 2, 3. Okay. Now, what is the valence electron of oxygen?
6, ma'am.
It is 6. 6. So oxygen got 6 valency electron, among which two were lone pair and two were bond pairs, right? So this valency electron of oxygen will get connected to carbon. So this electron and this electron will get connected. This electron and this electron will get connected. So one carbon is connected with one oxygen through double bond. We have two more oxygens, right? So for these oxygens, I'm going to draw the loose dot structure. Listen, central atom got one unpaired electron. This oxygen got one unpaired electron. These two unpaired electrons will get connected to form one chemical bond. And similarly, this carbon got one more unpaired electron. This unpaired electron will get connected to this unpaired electron. That's it. So I've connected the central atom with three oxygen atoms. Again, the formula is CO3 2 minus, which means I got two more electrons extra, right? So extra electron I'm distributing to each carbon. So one electron to this carbon and one electron to this carbon, right? Now the structure is a little clumsy. I'm going to draw a proper structure of carbonate ion. Carbon. Now this carbon atom is connected with one oxygen through double bond, and now this carbon atom is connected with another oxygen through single bond, but this oxygen got one more electron, which is extra electron, right? So due to the extra electron of oxygen, this oxygen will have negative sign. Similarly, this carbon is connected to another oxygen through single bond. This oxygen also got one extra electron, so this oxygen will also have one negative sign. So this is the electronic structure of carbonate ion. Now I can write the resonating structures for these. So this negative charge of oxygen can move here between carbon and oxygen. What is the valency of carbon? 4. Carbon can form only 4 chemical bond. If this negative charge moves between carbon and oxygen, carbon will gain another chemical bond which is unstable. Carbon's valency is just 4. Carbon cannot form 5 chemical bonds. Here I have 2 bonds, right? Among which one of the bonds will get transferred to this oxygen. So what will be the next structure? Carbon. Now double bond, single bond O minus. Now this double bond will get converted to single bond, and this oxygen will gain one negative sign, right? So this is another resonating structure. So I got two resonating structures here. Now there is another possibility. See, right side I have one oxygen now with one negative sign. So this negative sign may transfer here, right? So similarly, this oxygen, this chemical bond, that is pi bond of carbon and oxygen, may move to oxygen atom itself. So what will be the next resonating structure? C, single bond O minus, double bond O, single bond O minus. So these are the three resonating structures of carbonate ion, and there is no more canonical forms for this carbonate ion. The statement is three canonical forms can be drawn for carbonate ion, and the statement is true. Is that clear? Is that clear? Fine. As I've told you already, the tabular column which we have discussed today was very, very important. Definitely one question you'll get from hybridization directly or indirectly. For that tabular column is very, very important. Please spend some time in memorizing that. Not only memorizing it, you have to apply the tabular column. Just memorizing will not help. You have to apply the tabular column for all the examples, and after applying, it will be very easy, and definitely you can score 4 marks in hybridization, okay? Fine. Is that clear? Do you have any doubt? Fine. So shall we wind up the session today? If you have any doubt, please ask me. We'll discuss or we'll wind up the session. Okay, fine. So next class, we may discuss few questions from chemical bonding, and also we'll be starting thermodynamics. So please revise thermodynamics, okay? So next next class we'll be discussing questions from chemical bonding and thermodynamics as well. So please revise thermodynamics, okay? Fine. Okay, fine. Okay, we'll wind up the session. Okay, thank you, sir.
Thank you.